All right, going to do a video here on how to find the equation of a parabola given x and y intercepts. Now this can work with not only with these but with other points, although so I'm going to do it three different ways so that you could do it with any 3 points, but um, the first method requires them to be x-intercepts. So just to get an idea of what we're doing, we're going to sketch a quick graph of where these are. So if one's at minus 2, 0, and one's at 5, 0, and we have a y-intercept at negative 0, negative 6, then the parabola must have to go down and then go back up. But the main thing that we want to see out of this is that the center line has to be halfway between x-intercepts. Now, if we don't have the x-intercepts, if we have 2 points at the same height on the curve, down here at say minus 3, if we knew those 2 points, it would be halfway between them. But if they're not at the same height, then this method doesn't quite work. But since these are at the same height, they're both x-intercepts, the center line has to be halfway between them because a parabola is symmetric with the center line. So halfway between minus 2 and 5, we can get that by just going minus 2 plus 5 divided by 2. See, that's 3 divided by 2, or 1.5. That's the center line. Okay? That's also minus b over 2a. And so if I were to multiply both sides by 2 and well, let's see here. I can multiply both sides by 2a, and I would get 3 times 2a equals 3 over 2 times 2a equals minus b. And the 2's cancel, and I get 3a equals the opposite of b, or b equals negative 3a. So I know that, but these are a and b from this form. Where the quadratic formula uses a, b, and c in the quadratic formula, minus b over 2a plus or minus the square root of b squared minus 4ac over 2a. This is the center line. And this takes you from the center line to the 2, 0. So this represents these distances. But just using that, we know that 3 times this a is or this b is equal to negative 3 times a. So I could write y equals ax squared minus 3ax plus c, if that's the center line. And then I can use a couple of points to work this out, but the minus 6, 0 minus 6 in this form, this has to be minus 6. And oh, no, the y-intercept has to be minus 6, and that's if x is 0, this has to come out to be minus 6. So c has to be minus 6 in this form, so we get y equals ax squared minus 3ax minus 6. And now if I use either one of the x-intercepts in this, let's say I put in the minus 2 for x, I get 0 for y equals ax, putting in minus 2 for the x, minus 3a times negative 2 minus 6, and I'm supposed to get 0. So negative 2 squared is 4, so I get 0 equals 4a. Negative 2 times negative 3 is positive 6a minus 6. So I get 0, 10a minus 6. Add 6. Divide by 10. And I get a equals 3/5. And if a is 3/5, negative 3 times this times that is what b is. So b has to be negative 3 times 3/5, which is negative 9/5. So the equation for the parabola here would be a 3/5 x squared minus 9/5 x, and c is negative 6. That's one way to do this. Now let me show you another way to get it. Let's use the same form. And if I put in minus 2, I get 0. So I get 0 is equal to minus 2 squared, which is 4a minus 2b plus c. And if I put in the 5, I get 0 equals 25a plus 5b plus c. And if I put in the negative 6, I get negative 6 equals 0 times a plus 0 times b equals c. So right away, I know c is negative 6, which we did over there. So I have, if I go back to these two, I got 0 equals 4a minus 2b minus 6, and 0 equals 25a plus 5b minus 6. And at some point, you learned how to solve equations with two variables, two unknowns. Let's see, what would be the easiest? Why don't we have 10b in both of these? So I'm going to multiply this whole equation by 5, which will make negative 10b. And I'm going to multiply this one by 2, and that would be positive 10b. So 5 times all this would be 0 equals 20a minus 10b minus 30. 2 times all this would be 0 equals 50a plus 10b minus 12. If I add these two equations, 0 plus 0 is 0. I get 70a, these cancel, minus 42. Add 42 to both sides. Divide by 70. And a equals, let's see, 7 goes into both of these, and I get 6 over 10. 2 goes into both, and I get 3 over 5, the same a that I had before. I can put that in for a in either one of these and solve for b, and I can finish up getting my b. I already know c, and I can solve it that way. Okay, now a third way. If I use not the general form, the ax squared plus bx plus c, but if I use the transformational form, y equals a times x minus something or plus something squared plus a constant. Now this is the same a as before. This is not the b and this is not the c of the other one, so they'll look a little different. But if I use a transformational form, this needs to slide the graph over to 1.5. So it has to be x minus 1.5 times a plus c. And now I can pick one of the x-intercepts and the y-intercept, and I should be able to come up with two equations that I can solve. So let's use this one, put minus 2 in for the x, and the y would come 0. Minus 2 minus 1.5, that's minus 3.5 squared is 12.25 plus c. And if I put in 0, I get negative 6. So I get negative 6. If I put 0 in for the x, 0 minus 1.5 squared, that's 2.25. And if I just subtract these two equations, the c are going to drop out. So if I take this from this, so 0 minus a minus 6 is 6. 2.25 from 12.25 is 10 a's. And c from c is 0, so I get 6 equals 10a. Divide by 10, and I get a equal 3/5 here. So I have y equals 3/5 x minus 1.5 for the center line plus c. And if I put in, say, 0 for x and negative 6 here, I can figure out the c. Or I can put in negative 2 here and got to come out to be 0 and figure out what the c is. So that's 3 different ways to use the 3 points to find the equation. This method that I did here works for not only the intercepts, but any 3 random points. You can plug them in and get 3 equations, and then you have to do combinations of the equations to get the answer for the A, B, and C. All right, that's that.